Hi students, how are you? Happy Friday. Welcome to our first lecture for Intro to College Biology Lab. So I just went on a little bit of an adventure in my garden outside to try and show you a pill bug in real life for our lab. And it was actually a bit more difficult than I thought it was going to be. Here in New York, over the summer, it's actually been a bit of a drought. You know, we've had these thunderstorms, but it's been so hot and so dry in between these storms. So it's been very, very dry in my backyard. So I looked around a bit and I actually had a really hard time finding these pill bugs. But I did find one and then it got away from me. So I wasn't able to actually recreate the pill bug lab like I was gonna try to do. But we'll go through the slides and we'll talk about everything that we need to get through in the lab manual for you to complete the lab. But let me just show you my little bug hunt and then we'll get to the slide content. All right. Let's see what we have under my overgrown pots. Anything good? Doesn't look like it. Nope. All right, let's see if we can find okay, I'm not looking at. Wow, these are actually super hot. Nope, nothing in here. I finally found them. Alright, if you could see them, they're trying to hide from me. There was one, but he got away. So the first two places that I looked for the bugs were too hot and too dry, but this one is actually downhill from my downspout. So it rained yesterday from the thunderstorms, and so this soil is actually pretty moist, and it has, you know, a lot of woody stuff and detritus, which they eat, so it actually makes sense that I would have found one of these critters here. So, you know, I used my observation and I made a hypothesis, and I did actually find one of these bugs here. Hello students. Okay, so let's get started on our slides that I have posted on Blackboard. Just going over some administrative stuff just before we get into our science stuff this week. All right, so you should be able to find the contact info tab on Blackboard. It should be in the menu bar on the left-hand side of the page. And so if you click on the contact info tab, you should see my email and you should see the office hours by appointment via Zoom. And the Zoom link should be there. So if you just want to meet with me, send me an email and we'll set up a time and I'll send you the password and we can meet and we can talk. So the YouTube video links will be posted on Blackboard. I will embed them into the page so you can just, you know, just see them right in Blackboard, but then you can also go right to YouTube and look at them, whichever is easiest for you. My name on there is Kate, the science teacher, if you want to search me there. Okay, so just a little bit about how the breakdown of the class works. So the lecture is 60% of your grade. So this lab is basically encompassed in the lecture portion um, of the class. So the laboratory is 40% of your total grade. So I basically submit my part of the grade at the end of the semester, and that gets totaled in. Unless you are in Bio 10, then I submit a grade separately. So you have required textbooks. You have two books required for this course. You have the lab manual, which is the value edition created for Queens College, the BIOL11 lab manual. And then you also have the Plato to Darwin to DNA, a brief history. Um, and with that comes the code to access the online quizzes that you will be taking. So those quizzes are part of the class grade, and they're based on the content in that book. Um, so it has to be a new copy in order to receive that code. If you get a used copy, that code is going to be used, and you're not going to be able to access the quizzes. So make sure it's a new one. I know that there's often a delay with the bookstore, the online bookstore with Queens College, but I have heard that you are able to get ebooks. So if you have your ebook and you have access and you have your code, that's great. If you're still waiting for a physical copy of the book, that's fine. I know that shipping is not the best right now. I've been having a lot of issues myself. So if you're having a delay, don't worry, hang in there. I haven't set any due dates for the online quizzes yet, and I think I'm gonna probably push them back closer to the midterm for any of the due dates for these quizzes, um, just to give you all some time to get your books and to start reading. So if you are having any issues with getting these textbooks, please don't hesitate to email me and let me know how it's going. All right, so our online lab schedule. So, we're scheduled for Fridays. I think it's from 1:40 to 4:30 p.m. That was my usual block time for this lab section. Um, so we're asynchronous, which basically is just a fancy way of saying that you can do this course when you want to. I've never taken attendance in my lab. I'm not going to be keeping up on when you're doing the work for this lab. This is college and you should be doing your homework by now. Uh, I hope you're doing your homework by now. So you can do it when you want to do it. I will post the course content to Blackboard on Fridays, and then you complete the course content on your own pace, at your own pace. I think, so that we won't be meeting as a class really at any point during the semester, which is, kind of a bummer because I enjoy teaching this lab, and it's a very informal class when I teach it because, usually we go through our slides, and then we start doing lab exercises. And we talk about things, and it can be kind of fun and informal. So, in lieu of that, we could schedule a meetup to do a study or review session to go over some topics that you might want to address a little more before the midterm and before the final. And you can just let me know. I'll start a thread on Blackboard, and we can discuss that. Maybe throw out some dates and times that might work for everybody, and we can talk about that. All right, so the grading breakdown, which is in the syllabus, we have two lab manual gradings. Each of those are 5% each for 10% of that total 40%. So these lab manual gradings I will review at the midterm and the final. So I basically review the first half and then the second half. So these manual gradings, I will want you to take pictures or scan, however, and send me your completed lab assignments. So, we're not going to be doing the full experiments, so I'm not going to expect a fully completed experiment from these lab manuals. But, there are a lot of conceptual problems and answers in all of these labs. There are review questions at the end, and there are conceptual questions at the end that you can be thinking of and completing. So I'll be going through and I will put the questions that I expect to be completed in the posts that I'll be making every week. So, and I've never really been very strict about grading lab manuals, and I don't expect I'm going to be strict this year. I do want completeness. I want to see that you made an effort to do the work. I don't expect everybody to get everything right. That's not really what science is about. It's about making this a learning process. So please put forth your best effort. Um, don't scribble and don't leave a bunch of blank spaces. Uh, and you should be okay. Okay, so the 4 online quizzes, which is I explained a little bit, you're going to access those through the Plato to Darwin to DNA textbook. Those are 2.5% each, totaling 10%. And then we have the 2 lab exams, which are 5% each, totaling up another 10%. I'm not exactly sure how those are going to be structured yet, but I should be getting some more advice from Dr. Muehlbauer soon. So I will be addressing that very shortly, probably within the next week. So you all can have some preparation on that. And then the final 10% is going to be an essay. So the essay is basically a book review on the Plato to Darwin to DNA. So just talk about some things you learned, maybe your favorite part, something new that you might have learned, something that you thought maybe could have been expanded on more, just whatever you want. Please do not plagiarize. Please maintain academic integrity. I take that very seriously. But feel free to get a little creative about the essay. Talk about how maybe science or biology maybe changed the way you thought about something in your life that maybe you didn't realize science could be a part of your life. All right, so week 1, we are covering the scientific method. And you have my little cartoon, since I enjoy humor to get through these 2020 times. All right, so a little bit of biology and history. So the Plato to Darwin to DNA book is going to cover biology and the history of science pretty extensively, so I'm not going to go into that too much. But it really is a good introduction to our topic of the scientific method, because the very first step of the scientific method is observation. And how did early civilizations learn about their environment before they had all of these sophisticated tools that we have now? We have this explosion of technology almost to the point where scientists are struggling to keep up. But back then, they didn't really have this. They used the only technology they had, which was the 5 senses. So essentially, people could just use what they had to explain what they saw. And sometimes this meant that this was explained, a thunderstorm could be explained by Thor, the god of thunder. And so, while I am a Marvel fan, this is clearly not the explanation for thunderstorms in our atmosphere. This is not to say that all early civilizations got it wrong. We had ancient Egyptians who had extremely advanced medical textbooks and were performing surgical techniques that just, really blow your mind if you think about it. And we also had ancient Babylonians who were performing very complex mathematical calculations to explain the observations that they were making when they were looking at the planets and just seeing these astronomical phenomena that they were seeing. But really, it was starting from observation, and that is where the scientific method and the development of science began. So then, beyond just observation, just viewing your environment, you start to manipulate an environment, and you need a method for that. So we have something called an experiment. So what is the definition of an experiment? So we have a few definitions. We have a test or a trial. We have a tentative procedure or a policy. And then I've underlined a few phrases in the next portion of the definition here. An operation or procedure carried out under controlled conditions in order to discover an unknown effect or law, to test or establish a hypothesis, or to illustrate a known law. So what are the steps of the scientific method? It's basically a method to help you design and carry out an experiment to test a hypothesis. So you make an observation, and from this observation, you will start to make a hypothesis, which is basically, I've heard it just, described before, and you've probably heard it described before as an educated guess. So in my video before, you saw me sort of wandering around my yard trying to find these pill bugs. So, I've known from the past that they eat woody material, plant material, and they also like moist environments. So I was looking under my pots because it rained last night, and moisture in shaded areas is going to be more reserved under pots. But I wasn't finding it. So then I thought, okay, well, where is somewhere that usually stays moist? And I did find them in that shady area where I had a lot more moisture. But, I didn't really have much luck, as you saw. So, basically, I was just kind of hunting around randomly in my garden, but I was using a simplified version of the scientific method. So anyway, we formulate this hypothesis, and then we're going to test this hypothesis. So we're performing an experiment. We're looking to see if one variable is going to affect another variable. So in our laboratory manual, the experiment is that we are testing the behavior of a pill bug and how that behavior of the pill bug is going to change when we change the variable of a substance being exposed to that pill bug. So I think in the manual we have soda, water, various other liquids, and then we have ketchup and flour and some sand as some solid substances. And so this is going to test our hypothesis that based on what we know about pill bugs and how they get oxygen with their gills, because they are more closely related to crustaceans than other insects, that they need moisture in their environment. How are they going to react to all of these different changes in their environment? So then we would have watched these pill bugs and how they reacted to all these substances. We would analyze the results, and then we would draw a conclusion. And that is basically just, could we reject or accept the hypothesis? So I basically formulated a hypothesis that I was going to find pill bugs in the most moist environment that I could find in my yard. And I did find pill bugs there. So I would accept my hypothesis. So after you do this for a while, you can develop a theory. And if you notice in my graphic, in my slide, you could see that this is a circle. This isn't really just a line. You don't just make an observation and then draw a conclusion and then that's it, you go home. It really is a circle. You will continue to do this and build upon your own work, but you will also build upon the work of other scientists. So it isn't always just going out and making your own observations. You will read the work of other scientists. You will talk to other scientists. And this is also in other fields. So when you're working on, say, a business, you're going to go out and speak to other business owners. What worked for them or what didn't work for them? This is a method to do a lot of different things, not just science. All right, controls in experiments. So these are very, very important. The scientific method is the entire point of it is to design an experiment, a good experiment, so that you can very confidently accept or reject your hypothesis. And if you don't have these controls, you really don't have a good experiment. So a negative control is a sample or an event that is not exposed to the test conditions. So what are these test conditions? The test conditions in the book are these ketchup or the flour, the Pepsi, whatever, is listed in these lab manuals. The negative control that we have are listed as the water and the sand. So these are two substances that a pill bug is probably going to encounter in its normal natural environment. So that's sort of um, a neutral substance for a pill bug. So you can basically use this negative control um, as a way to gauge your experiment. So you can use that negative control to compare the results of your test sample. So you might want to use that as a baseline. So you might want to set that as a 0, and then you can compare the change in your test sample, or use that just as sort of a quality control for your test. So if you see that the negative control and the test sample produce the same results, either the hypothesis is false, there's no change, or if you see something else, this can also show you that the test was flawed. So this can happen. Sometimes there's contamination in the sample, or you could see that the machine has malfunctioned. Nothing is perfect. Things happen in science, and this is important. This is why you have to have controls. Um, Carefully designed controls will tell you when your experiment goes wrong. All right, so this week's lab. So we learned a little bit about the pill bugs. I posted some information. The PBS video should give you a little bit more information about the pill bugs. I thought it was a great video. It's about 3 minutes, or you could just read the article. It's really the same information. But they are land crustaceans, so they are more closely related to shrimp. And like we saw in my little video, they live in damp places. They feed on dead organic matter, like the plants that I had in there. They also have an exoskeleton, which is basically that their skeleton is on the outside. Um, like us, like humans, our skeleton is on the inside. We have an endoskeleton. Pillbugs also have gills, like the aquatic animals, like the shrimp, their relatives. And so gills, like the aquatic animals that live under the sea, they need water for these gills to function effectively for gas exchange. Basically, gills need water flowing over them at all times in order for oxygen to be transported across these membranes to get oxygen into the cells in order for these animals to live. So that's very, very important for their survival. They will not live if their gills become dry. They will die. And in this picture, you can also see that they have this defensive mechanism where they roll up into a ball. So when I was growing up, I called them roly-polies or potato bugs because they would roll up like this, which I guess, looks like a potato, and maybe. um, and so they have 3 body parts. They actually have a head, and they have a thorax, and then they also have an abdomen. And so we will see later on in the semester where we start to identify these different body regions and how they differ across um, different families and different kingdoms of animals. So as we start to learn our comparative anatomy and how that allows us to study changes through evolution. Okay, so if you have any questions, please feel free to email me. Work through the laboratory manual questions. I will put them in the announcement, which ones I want you to complete. But really just use, common sense. If it seems like you would have had to do something in the lab that you don't have access to, I probably don't really want you to complete it, or I'm not going to worry about you needing to complete it. Okay, I hope you all have a pleasant weekend, and I will see you next week for Lab 2. Thank you. Have a good evening. Bye.